In this video, we'll explore Grid and Snap. These two features allow you to draw objects constrained in space. Go down here to the status bar and toggle on these two modes, Grid and Snap. To control their spacing, click this arrow and choose Snap Settings. This opens up the Drafting Settings dialog box, and we're focused on the Snap and Grid tab. You can toggle on and off Snap with F9, and you can toggle Grid with F7. By default, the snap spacing is 0.5 centimeter in both X and Y directions. And Grid is the same. Let's change Grid so that we see a grid line every centimeter. So I'll type 1 tab here. And I'd also like to set up the grid so that there's a major line every 10 centimeters. So I'll change this to 10. If we were using inches, it would be best to set a major line every 12 inches or every foot. Over here, this is a major line, and these are minor lines inside. I'm going to leave Adaptive Grid checked so that the grid density is limited when you zoom out. And I'll leave this unchecked so that the grid won't subdivide smaller than 1 centimeter. Let's make sure that we have Grid Snap and Rectangular Snap selected and click OK. So now what we're looking at is a grid with major lines every 10 centimeters. So each little box inside of here must be a square centimeter. And if you zoom in by rolling the mouse wheel, you'll see that the grid does not subdivide below a centimeter. I'll zoom out, and at a certain point, things get simplified. So we're not looking at the individual centimeters anymore. We're just looking at every 10 centimeters. I'll zoom back in a bit. This gives us a good visual indication, just like graph paper does, of the regular organization of space. Let's go ahead and draw a line. And as I move the cursor, notice what's happening. It's sort of jumping. That's because of snap. We're snapping to every 0.5 centimeter. You see that? I can snap to these intersection points of the minor lines, and I can also snap midway between them. So I can draw a line along here, and I can tell just how far it is. And I don't have to enter any numeric values. I can just rely on Grid to help me determine how big things are. And I'll just go ahead and draw a rectangle and press Enter to end that line command. So it can be nice to use Snap in situations where your geometry happens to conform to such a scheme. And I'd say generally that's rare unless you're making mechanical parts that just happen to come in 0.5 centimeter increments. A more flexible approach that we'll cover in a future video is Object Snap, and that allows you to snap directly to geometry that you draw in space. But this more primitive or more fundamental system of Grid and Snap allows you to draw objects that happen to conform to a regular grid. So let's go ahead and draw another line here. And you see that I can't draw it to any place other than this spatial grid. If I wanted to, for some reason, draw a line to some other arbitrary point, I would have to come down here and toggle off Snap. Now the cursor moves smoothly, and I can click anywhere I want. Alternatively, we could hide the grid and use Snap. And then we have that sort of implied grid. Although we don't see it, it's still there and it's still operative. And we don't have to use ortho, and we don't have to use Object Snap. So there you have it, Grid and Snap, two aids that assist when you're creating objects that happen to conform to a spatial grid. In this video, we'll create an isometric drawing. Isometric drawings are two-dimensional illusions that represent three-dimensional objects, but they're not truly 3D models. This is perfect for AutoCAD LT, which doesn't support 3D modeling. You can actually represent a 3D object in isometric. To enable this in AutoCAD, you need to turn on a status bar toggle called the ISO plane, and you can access that on the Customization menu under Isometric Drafting. That adds this control to the status bar. It contains 3 different planes, left, top, and right. We'll start with the left plane. Click here to enable isometric mode. The icon changes to a red and green symbol. The cursor also matches that. The x-axis is red and the y is green. Let's also turn on ortho and snap. draw a line, and let's draw the left side of a mechanical part. We're viewing it from above and at an oblique angle. Now I need to change the isoplane so that I can draw the top. Draw another line and snap it to what you've already drawn. Now here I overshot. This is easy to do because it's hard to line it up. I'm going to move this over, and unfortunately it didn't make it. Let's try another method. Erase the line, draw another line, and I'm having trouble snapping here. So I'm not able to use grid snap. I'm going to have to resort to object snap. Hold down Shift and right click and choose endpoint. Then select this particular endpoint. Let's draw another line from here, and this time the intersection corresponds with a snap point, which is tied to the spatial grid. And then I'll do another one here, and evidently this point doesn't correspond to a snap point either, so I'll have to use object snap. Hold down Shift and right click, choose endpoint, snap to that point, and draw a line over. We'll draw another line down here using the same method. And then we should be able to draw lines to connect these in the right view. So we need to change the isoplane to right, and then use the line tool again. Here I need to snap to the intersection, right there. And it looks like I'm drawing the left side again. So I could just copy what I've already drawn here from here over here, but I'm going to have to snap it to endpoint there. Now we need to clean up these lines which overshot their targets. To do that quickly and easily, I'll type TR for trim, enter, and press enter again to select all the objects as boundaries, and then I can simply click on the parts of the lines that I don't want. So there we have it, an isometric drawing that represents a three-dimensional object on a two-dimensional surface. If you want to go back to the way the coordinate system was before, you have to toggle off isometric drafting and the cursor returns to normal. In the next video, I'll go into more detail about coordinate systems. In this video, I'll discuss coordinate systems. Coordinate systems are used to measure objects, and there are two primary systems that we use in AutoCAD. Cartesian, named after René Descartes, the famous Enlightenment philosopher and mathematician, and polar. AutoCAD also supports cylindrical and spherical coordinate systems, but these are only used in 3D modeling. We use Cartesian and polar coordinates all the time. In fact, they're both operative when you do something as simple as draw a line. Click the line tool and turn on dynamic input down here on the status bar if it's not already on. What you're seeing here are two numbers representing x and y coordinates. This is the Cartesian system. René Descartes came up with this idea that we could represent any point in space as a combination of these two values, x for the horizontal axis and y for the vertical axis. In AutoCAD, we can use dynamic input to see those graphically or to type in numbers directly. I'll type in 15 tab 10 to specify some absolute coordinates. So this initial point is 15 units over in x and 10 units up in y relative to the origin point of the grid. Normally we don't do that. We don't care where a line starts from. But I'm just highlighting this to show you that you can actually input absolute coordinates here. Cartesian coordinates aren't so useful when you're drawing lines, but they're more useful when you draw rectangles, and we'll do that shortly. Right now, for the next point of the line, AutoCAD has automatically switched over to using the polar coordinate system because it's much more useful at this stage. When we're drawing lines, we generally don't care about their x and y coordinates. Instead, we're more concerned with how long the lines are. So the polar coordinate system measures the distance away from the pole That is the initial point. If I bring the cursor down here, you can see the value gets really small. If I move it further away, it gets longer. The other portion of polar coordinates is the angle, and you can see that value changing as I move the cursor. So we can enter these values by typing 15 tab 33.3, enter, and so I've specified that second endpoint using polar coordinates. Let's draw a rectangle next. I'll specify its first corner point at some arbitrary location. I'm not concerned with the absolute location of that relative to the origin point. But the next point is relative to the first point. You see, the next point values are relative to that first point. If I bring the cursor right back here, I get all the way down to 0, 0. So it's almost like the origin point is that first point that I clicked. So the second point is going to be determined by the length and width, or x and y coordinates. So I can type in 15 tab 10, enter, and then we know for a fact that this rectangle is 15 units wide and 10 units high. We don't really care where it is relative to the origin point. Now let's say I want to draw a line from the origin point so I can see where it is. I'll type L, enter, 0, 0. The comma is used as a delimiter to separate the x and y coordinates. It's an alternative to using the tab key with dynamic input. The advantage to using the comma is it works even when you're not using dynamic input. So there's the origin point. We can verify that also by turning on the user coordinate system icon. Type UCS for user coordinate system and then icon. Turn that on and you'll see it right here. It represents the directions for the x and y axes. And the point right there is the origin point of the grid. I'll turn on the grid and you can see that it lines up there. It's important also to be able to type in Cartesian or polar coordinates on the keyboard. So let me show you how to do that next. Draw a line from some arbitrary location, and I'll use the keyboard to type in Cartesian coordinates. Even though dynamic input is showing me polar coordinates, it doesn't matter. I'll type in 5, 10, and that forces it to use Cartesian coordinates. Enter. So now I know this endpoint is 5 units over and 10 units up from that first point. I'll draw a rectangle, and this time I'll use polar coordinates to locate the opposite corner. I'll type 10, and then I'll use the angle symbol. On the keyboard, it's the less than symbol above the comma key, so I have to press Shift, comma, and you'll see that little angle symbol there. Now it's forced AutoCAD to use the polar system. So I'll say 10, angle 45, enter. And so now this is a square because this distance is 10 units across from corner to corner, and it's at a 45-degree angle. So you can choose which type of coordinate system you want to use, depending on whether you type a comma or an angle symbol to differentiate between Cartesian and polar coordinates. In the next video, we'll talk about ortho and polar used in conjunction with direct distance entry. In this video, we'll take a look at polar tracking and compare it with ortho. Start by drawing a line and turn ortho on down here on the status bar. As the icon suggests, ortho constrains your drawing to orthogonal 90-degree increments. So if I draw a line here, I can only draw it horizontally or vertically. I can click points here without having to worry about the angle. I can just type in a distance, say 12, and press enter, and AutoCAD will draw it horizontally. If I move the cursor down in this direction and I type 12, enter, it's going to understand that I want to draw it down because of the location of my cursor. So if I move the cursor over this way and I type 20, enter, there's no need for me to type in the angle because ortho is taking care of that for me. So ortho is used quite a lot because most objects that are manufactured have right angles. Most buildings have right angles for the walls, and so this is quite handy. However, There are many situations where you will want objects to meet at something other than a right angle, and you would use polar tracking for that. Let's turn off ortho and turn on the neighboring icon, which is polar tracking. Polar tracking is controlled with this menu, and you have different sets of angles you can snap to. Let's start by selecting this top option, 90, 180, 270, 360, and so on. That's very similar to the way that ortho works. Draw a line from some arbitrary point and see what happens here. We have a green dashed line representing the polar tracking, and it works very much like ortho. I can type in a distance, say 10, and press enter, and AutoCAD will draw that horizontally. However, I have more flexibility here because I can actually draw a line at any angle that I want. I can draw one up here, I can draw one over there, but I can, if I want, snap to this green dashed line. I can draw a line down here that's 6 units long. I'll type 6, enter, and there's no need for me to type in the angle value. Of course, you can override this at any time by typing in values. I could say 10, angle symbol, 15, to draw a line 10 units long at a 15-degree angle. You can change the set of angles here to a smaller increment. Let's try 30, 60, 90, 120, and so on. And now I can go ahead and draw lines with more choices here for the angle that I'm going to snap to. So depending on what you're drawing, you basically just look at it and say, okay, does this conform to some kind of polar orientation? Like, are there a lot of angles that are 30-degree angles, or are they 45-degree angles? And you just choose the right sequence of angles here. You can also set up your own angles. If you have some odd angles, you can add them in here by clicking New. You can toggle polar tracking on and off with the F10 key. In the next video, we'll go over the dynamic input system in more detail. If you've been watching the videos in this course in a linear fashion, you've seen me use dynamic input many times. But if you're jumping in here, I'll show you how to use this system, and I'll give you even more detail about how it works. So let's draw a line. And right now, I'm seeing the dynamic input. That's controlled here with this status bar toggle. When that's off, I don't see that information next to the cursor. When it's on, we have the command prompt. It says the same thing down there on the command line, specify first point. And we also see 2 coordinate values for the x and y coordinates. As I go through the command, it switched to the polar coordinate system. And it also is reading me the prompt, specify next point or down arrow. There's one option at this stage, which is undo. Right here, I can click that on the command line, or I can press the down arrow on the keyboard to open up this menu where I could choose undo here. Alternatively, I could type in U enter on the keyboard to execute that option also. So there's no shortage of options here. Some people like the dynamic input prompt because it's right there where you're working in front of you, and others find it distracting. It's really a personal preference. I'm going to right-click on this icon and choose Dynamic Input Settings. That's going to bring me here to the Drafting Settings dialog box where I have lots of detail about how to control what I'm seeing here. Now let's say I disable pointer input. See what happens now. If I draw a line, it doesn't say anything. I can click a point, and now it displays the polar coordinate system, just like it did before. But it doesn't bother me with that initial information. So in a way, that's better. But if you're a new user, you might want to leave that on. Let's go back there again. Right-click on the icon and go back to Dynamic Input Settings. Now I'd like to re-enable that and go to Settings. Here is where you can control whether the second point is shown in polar format or Cartesian format, and whether it's relative or absolute. I think the best option here is already selected, polar and relative, because the second point that you click really should be relative to the first one that you've already entered. And it's usually most useful to use polar format for that. But you have the option. Also here you can choose to display the tooltips all the time, or only when you're asked for a point, or as soon as you type anything. So again, choices are many. Here we can type in values when we're drawing a line. We have a dimension value. We can input a number there, and I find this very helpful. But you can turn that off if you don't like it. And you can adjust the settings here so that it just shows one dimension at a time or two. Let's try one. Okay, draw another line. Now it just shows me the length. It doesn't show me the angle. If I specified a length, say 10, and pressed Tab, it would show me the angle. But I sort of have to know that that's a possibility. And so if you're just starting out with AutoCAD, that might be a bit confusing. But as you gain experience with the program, you might like to streamline it a bit so that there's not so much visual clutter on the screen. And so that's what some of these options are used for. I'll just go back in there and turn that back on. Finally, you can show command prompting and command input near the crosshairs or not. That's the prompt. If I turn that off, it's not going to bother me with repeating what it says on the command line. It doesn't say specify first point anymore. In a way, that's appreciated because I don't like to have duplicate information on the screen. But again, it's up to you, and perhaps when you're learning, you might want to leave everything as it is. And as I said, as you gain experience, you can turn off some of these prompts, which you might find to be distracting. In the next video, we'll examine Object Snap. Object Snap allows you to precisely connect objects using the geometry itself as the guide. In this video, you will see several manual and automatic methods of using Object Snap. Open the mechanical sample file from the Chapter 6 folder. We have a top view and a right view of this part. I'd like to draw the front view. To do that, I'm going to find it easiest if I snap to the existing geometry and project the lines over and down so that I can construct this front view. I'll start by drawing a line, and the first point will be snapped to something up here on the top view. You can call for snap one at a time by holding down the Shift key and right-clicking. This opens up the Object Snap menu. I'll choose Endpoint. And then as I bring the cursor closer to this geometry, you'll see that a green box will appear. This is the endpoint symbol, and if you hold the cursor still for a moment, you'll see a tooltip that reinforces that fact, endpoint. Many of these objects have endpoints, and so you can snap to any of them. There are no endpoints on the circles, of course, but there are endpoints on the end of the lines and the end of the arcs, and everywhere you have the end of a line, you have an endpoint. So in this case, I'll snap a line to this endpoint, and with ortho on, I can project it down, and then press Enter to end the command. Now I'd like to draw a line over horizontally from this point, and I'll do that again. L, Enter, and I'm finding it a little bit tiresome to have to hold down Shift and right-click. You can type in 3-letter abbreviations for the object snaps if you prefer. So I could just type END for end, Enter, and now I have endpoint snap available. If you're finding that you are calling for a specific snap over and over again, which would be the case in this project, it makes more sense to turn on automatic or running object snap. And you can accomplish that right here. Click on this arrow and you'll get a menu of object snaps just like you do when you hold down Shift and right click. But this menu refers to snaps that are on continuously. So if I turn on endpoint here, it's going to stay on until I toggle it off. So now I'll draw another line, this time from this point down, and another one here. And you see this method saves a lot of time because I don't have to keep calling for the snap over and over again. You can toggle on multiple modes simultaneously. So I could turn on midpoint, center, quadrant, and intersection. Let's see what they do. I'll draw a line from the midpoint here over. I'll draw a line from the center of the circle. That appeared when I moved the cursor over the circle. It realized, oh, there's a center, I'm going to display it, and there it is. If I move the cursor over here towards this circle, it will suddenly display its center point. Every circle also has 4 quadrant points located at the north, south, west, and east points of the circle, if you will, every 90 degrees. That's also true for arcs. Arcs also have quadrant points if they go through those angles. In this case, this arc doesn't, because it has an end point, which is essentially where its quadrant point would be. It also has a midpoint, and circles don't have midpoints. So I could draw a line from that quadrant over if I wanted to. You can also connect objects to intersections of other objects. So right here I have these intersections that exist now that I've crossed lines. So I could draw lines connecting them like that. This isn't exactly the right projection, but I'm just demonstrating the use of snap here. Now, another useful snap is called perpendicular. And I can draw a line from any arbitrary point over here, and then I can snap it to be perpendicular to this line. So it's precisely connected there. Whenever you snap, the objects are connected absolutely exactly to 8 decimals of precision. So you're not going to find any gap in there, no matter how closely you zoom in. The way that object snaps work is with the green symbol. So if I bring the cursor over here and I see that green symbol, I can click now and it will snap to go perpendicular. There's no need to try to bring the cursor in as close as you can. As long as the green symbol is illuminated, you are assured of having that snap happen if you click. Now, one snap to be cautious of is nearest. I'll turn that on and just show you how that works. If I click a line here, I can snap it nearest. That means anywhere along the line. I can also go perpendicular. But what tends to happen if you have nearest on as a running object snap is it will occasionally interfere with another snap. Like if I was here and I clicked right there and I thought it was going to go perpendicular, it might not actually be perpendicular. It might be nearest. So because of that potential for confusion or for a mistake, I recommend that you don't use nearest as a running snap. Instead, if you need nearest, call for it explicitly by holding down Shift and right-clicking, for example. So if I wanted to draw a line from here to some point along this line, I would hold down Shift, right-click, and click nearest here from this menu. Alternatively, I could draw a line and then type NEA, the first 3 letters of the word nearest, and then that would work just as well. You may notice that there is another snap called none. If I draw a line here, and I don't really want to go perpendicular there, but I want to draw it close to that, I could then hold down Shift, right-click, and choose none. And just for this moment, while I'm finishing up this command, none of the object snaps will work. I can then click it really close to that line, but it won't go perpendicular so that it's joined. So this is how you can override all of the running object snaps on a one-off situation. You can call for a none snap. Alternatively, you could just toggle off all of the snaps by clicking this icon. And then you can click there without snapping. But then you have to come back and toggle them back on. An even faster way is to use the F3 key. It toggles snap on and off. So you can be drawing and say, oh, I don't want to snap there. I'll just press F3. And then you can avoid snapping. So I recommend leaving many of these modes running. You can leave probably all of these on. I don't tend to use apparent intersection or parallel very often. Apparent intersection is something that happens in 3D when something looks like it intersects from a certain angle, but it doesn't actually intersect. And parallel isn't something you need very often. You can just offset a line. An extension is kind of an interesting snap because it's going to snap to a point that would exist if the line were longer. So let me show you that. I'll draw a line from here up here, and I need to turn on snap as well, F3. Now I can snap right there to that apparent intersection. The lines don't actually intersect, but there's a little X there that means I can snap to that point. And that's happening because of the extension snap. Point objects use the node snap, and text objects and blocks have insertion point snap. Tangent snap refers to a single point of intersection between an arc or a circle and a line. So, for example, over here, if I draw a line tangent to this circle, it will cross through that circle in exactly one point. So there are two tangents on this circle. There's one there, and there's one down here, relative to the first point that I clicked on the line. So object snaps are extremely helpful in AutoCAD, and I use them every day. I recommend that you get used to them. It obviates most of the need for using grid and snap over here. Object snap is much more flexible. I would only use this kind of snap if the part I was drawing conformed rigorously to a grid, and that's rare. Most of the time objects don't perfectly correspond to a grid, and you're going to want to use object snap instead. So there you have it, my whirlwind tour of object snap. In the next video, we'll take a look at a specific type of object snap called from snap, and we'll also look at temporary construction geometry. AutoCAD 2016 has a new type of object snap called geometric center, and this works on closed polylines, which I've drawn here on the left. As you see, I also have a circle on the right. Let's say we want to draw a line connecting the geometric center of the closed polyline with the center of the circle. Go to the Line tool, hold down the Shift key and right-click to open up this Object Snap menu. Choose Geometric Center, and position the cursor over the polyline edge, and you'll see this Geometric Center icon appear, which has these 8 points. I can click right here to snap to the geometric center. Hold down Shift and right-click again and choose Center, and then click on the edge of the circle to snap to its center, and press Enter to end the command. If I select the polyline and change its shape, obviously its geometric center is now in a different location. I can toggle on the running object snap mode, geometric center. Notice that center is also running. Now I can draw another line from the center of the circle to the geometric center of the closed polyline, but actually when I did that, I clicked a little bit too close to the endpoint, and it decided to snap there instead, because endpoint is also one of my running object snap modes. So I've got to be a little bit more careful. Let me erase that line. Try again. Line from the center to the geometric center. I'm going to come over here and actually click on it. And now they're connected. The geometric center can be useful when you're calculating the center of mass of an object. It analyzes the two-dimensional shape and finds the center point. There's one other place you can find the geometric center, and that is in the Drafting Settings dialog box, which you can access by going to this item in the list, Object Snap Settings. It's listed right here, along with all the other running object snap modes. In this video, I'll talk about from object snap and some temporary construction objects that you can optionally create to lay out your drawings. Let's say that I wanted to start this drawing of the front view at a point that is 10 units over from this particular point right here at the intersection of the arc and this line. Now I could just draw a line there and snap it to that point. And using ortho, I can move the cursor to the left and type 10, enter, and that identifies a new point to start drawing my front view from. I could then draw a rectangle and snap it right there and continue drawing the front view. Alternatively, I could identify this point using from object snap. And the advantage to that is that I don't have to come in here later and erase this particular line segment that I used as a construction geometry. Let me show you how that would work. I'll draw a line, but instead of snapping it to this point, I'm going to shift, right click, and choose From. From is going to defer the point that I'm going to snap to until later. I'm going to click here, and this is actually the quadrant point of the circle. And if I move the cursor slightly, it will shift to the end point of the line. And if I move it around some more, we'll see the intersection of the arc and the line. All three of those snaps are coincident, so it doesn't matter which one you click. I'll click here, and now the prompt says offset, and it gives me 2 coordinate values. I want to specify a point that is 10 units to the left horizontally from the point that I clicked. So I can do that using either Cartesian or polar coordinates, whichever you're most comfortable with. In this case, I'll use Cartesian, and I want to use relative rather than absolute, so I'm going to have to type in the @ symbol to specify that I want relative coordinates, that is relative to the first point that I clicked. Now I'll type in -10, so that means move to the left along the x-axis, comma, 0. So I don't want to move up or down in the y-axis at all. I just want to move to the left 10 units relative to the first point that I clicked. Now I'll press enter, and the line begins from that point that I'm looking for. So this method has a bit more overhead associated with it because you have to think about, okay, how am I going to specify that point? I'm going to have to type in coordinate values. Okay, so I don't know if I would use this method. I think I'm more inclined to just draw some temporary geometry and then erase it later. That seems to be more straightforward to me. But from is there in case you want to skip that step and specify an exact point that isn't actually on an object. So this is interesting. You're using object snap in a way where you're able to snap to points that aren't even on objects using from snap. Now let me show you a couple of other ways you can create temporary construction geometry that you will erase later. So let's say I want to lay out this drawing over here, and to do that I'm going to have to draw a bunch of lines. So I could either draw those lines or I could use some aids here that are available on the draw slide out. There's 2 of them here, construction line and ray. Let's start with construction line. It will actually make a line which is infinite in length. And all you have to do is specify a point where it starts and a direction. So if I click right here on this endpoint and move the cursor down and click, I have drawn it. Now I will press the space bar to end the command. And just to show you, I'll zoom out. It doesn't matter how far out I go, this line will go on forever and it will always go off the screen. Well, that's fine. I don't really know how long the line is supposed to be yet. So it's helpful just to draw some construction lines here. I'll go ahead and offset that. I'll use the offset tool. And then I'll offset that from here to here. And I'll just go ahead and offset that. And I can have an additional construction line there. Now I might want to draw yet another construction line. And the command on the keyboard is X-line. And I'll click here, and then using ortho, I'll click to the left to create another one. And then again down here, and again over here. So I've blocked out my front view using these temporary construction lines. Now if I use trim, I can then cut away at these construction lines and make them of finite length. I'll press the default select all by pressing enter to select everything in the drawing as a potential boundary, and then I can go ahead and trim away some of these construction lines. Now if you zoom out, you'll see what happened. I cut away these okay, but this one continues on, so I'm just going to have to erase that one. Now over here, these seem to go off the screen forever, and they're not construction lines, they are rays. This is a ray because it starts at a point and goes on forever in one direction. And I can convert that into a line by trimming it. So I'll choose trim. I'll select this construction line particularly as the boundary and then press enter. Then I'll trim these 2 rays off. Press enter again. And now these have been converted into lines that have a fixed length. I'll go ahead and trim again, click trim, enter, and then I will just trim these off. But this method left me with these rays that appear that I need to then delete. I did that by making a crossing selection and by pressing the delete key on the keyboard. It's an alternative to using the formal erase command. So in this method, I've locked out my front view diagram using some construction geometry. You also learned how to use the from snap to specify a point, a set distance away from a given object snap. In the next video, we'll take a look at object snap tracking. Object snap tracking is like having temporary construction geometry that erases itself after you're done laying out a drawing. In this video, you will track points and snap to them. Open the mechanical sample file in the Chapter 6 folder. Then turn on Object Snap Tracking down here on the status bar. It's adjacent to Object Snap. Let's also have Ortho on. And then go ahead and click the Line tool. Move the cursor over here to acquire a tracking point. The snap could say quadrant, endpoint, or intersection, but all three at this location are coincident, so it doesn't matter which one appears. However, be careful not to click, because we don't want to start drawing at this point. All we want to do is acquire the Object Snap Tracking line, which appears when you move the cursor to the left. If it doesn't appear, go back and try to reacquire it. You see, each time I do that, I either get it or I don't. I'll reacquire it now. This dashed green line works just like it does in polar tracking. It allows you to snap along that direction. So I can draw a line that is lined up with that snap point. I'll select that line and delete it. You can also intersect object snap tracking lines, and I'll show you what I mean next. Draw a line, and without clicking, move the cursor over here and acquire this tracking point, and then move the cursor to the left. Then carefully come up here and acquire this point as a tracking point and move the cursor down. And as you come down here, you're going to find a point where those two dashed green lines intersect. I can click here to start drawing my line exactly from that point. This is an alternative to drawing temporary construction geometry or using the from object snap. Object snap tracking can get a little confusing though if you leave it on. If I come in here and start moving around, you're going to get all kinds of weird green lines appearing here. So I tend to only use object snap tracking when I need it, and then I'll turn it off when I'm done. You can press the F11 key to toggle this mode on and off. In the next video, we'll take a look at user coordinate systems. By default, AutoCAD uses what is called the World Coordinate System, or WCS for short. It's possible to create your own user coordinate system, or UCS, that has a different origin point, or is rotated with respect to the WCS. You will create a UCS and draw objects using it in this video. Open the mechanical sample file in the Chapter 6 folder. Let's turn on the user coordinate system icon by typing UCS icon, enter, and then choose on. This represents the X and Y axes, and this box is located at the origin point of the grid. If you click this icon, you can then move the UCS to a new location. I can move this down here, and what I've done is I have moved the origin point, and I've created a UCS at the same time. Notice, though, that there's no longer a box around that point. That means I'm dealing with a user coordinate system. The world coordinate system was the initial one. So now we're working with something that's a little bit different. Now, so at this point, it doesn't really matter. Why would you care if you move the origin point? Where this comes in handy is when you start to rotate the UCS. And you can do that with these grips here. I'll click this grip and I can rotate that. And watch what happens to the cursor. It also rotates. I'll press escape. Now, if I draw a line and turn on ortho, you will see that the line is working with this new coordinate system's orientation. And so this can come in handy if you're trying to draw something that's at an angle. So let me just erase these. Notice that you cannot erase the UCS. It's a drawing aid that remains on the screen. You can turn it off, but you can't get rid of it. I could type UCS icon off, but I would still have the benefit of this rotated coordinate system. Now over here, let's say I want to draw in this little area and make it bigger. I'm going to move the UCS over there, and I will snap its origin point right there on the corner. And then I'm going to grab one of these grips and rotate it around like so. Now my coordinate system lines up with this geometry. At this point, I'd like to stretch this part out so I have a larger surface that's at this angle. If I use stretch, the selection window is still in the WCS system. So I have to be really careful about how I select that. And I can just do it here. I can just select those objects, enter, and then I'll click a point here, turn on ortho, and drag that over. So I have now a larger surface to work with, and it has maintained the same angle, a 45-degree angle going down with respect to the horizon. You can also rotate the user coordinate system using the keyboard. You can type UCS, enter, and then you can type in the axis that you want to rotate around. In this case, I want to rotate around the Z-axis. That's an axis that comes out of the screen, perpendicular to the XY plane. I'll rotate around the Z-axis 45 degrees, and that rotates it back so that it's horizontal. Another way you can work is by orienting the UCS relative to a selected object. So for example, let's say that we draw a rectangle over here, and then we rotate that at some arbitrary angle. I'm just going to rotate it about like that. Now I want to work with that, and I want to draw using that as my reference. So I'm going to type UCS, enter, and then I'll use the object option right here. Click on that, and then click on the object. And automatically the UCS will move its origin point and rotate itself to suit that object. Now I could go ahead and draw a line using ortho that is relative to that geometry. So in this way I can detail something that's at an angle. You can also view that information as if it was in front of you like a floor plan, like you're going to rotate the paper so that you're looking with the x-axis horizontal and the y-axis vertical. And you can do that with the plan command. Type plan, enter, and then you're going to use the current UCS, which is the default option. So just press enter again. It's like rotating the sheet of paper, if you will. So now we're looking at it like a floor plan, like we're looking at the sheet of paper with respect to our UCS. So if we had an extensive amount of work to do in this geometry, we could do it. And then when we're done with that, we could go back to the initial orientation by resetting the user coordinate system first, UCS, enter. And I'd like to reset that back to the world coordinate system. So I'll choose this world option. It's actually the default option. So all I have to do is press enter. And now the UCS is gone and we're back to the WCS. Now it's very subtle, but I can tell that this is the WCS because there's a little box right here. Now I want to rotate the drawing, so I'm looking at it orthogonally, and I can do that with the plan command again. Plan, enter, and I could either go to the current UCS or I can choose the world option. They're equivalent in this case, world. And now I'm back to where I was. So there you've seen some interesting ways to reorient your coordinate system to suit the type of work that you're doing. Of course, in 3D, you can rotate the UCS at any angle on any surface, and this becomes invaluable when you're doing 3D modeling. But it's also quite helpful when you're doing 2D drafting, when you're trying to draw objects that are at an angle.